Alright, this video is going to help you understand how to use the discriminant, as we call it, note the word up at the top there, discriminant, to determine whether or not a graph crosses the x-axis, whether or not a quadratic graph, a quadratic equation, crosses the x-axis. Now, first of all, we have to kind of understand where the discriminant comes from to understand why we use it. So tomorrow, or likely days to come after today, you will use the quadratic formula. Now that's the big formula over here, right, at the left. Now we haven't used that yet, so don't worry about understanding the entire idea of it. But the main thing is the discriminant is just a small part of that larger quadratic formula. It's this piece underneath the root right here. Okay? And the reason that we care about the fact that it's under the root is, remember, we can't take the square root of negative numbers. So if we can find the discriminant, again, this formula at the right, the b squared minus 4ac, right, over here, if it comes out to a positive number, then we should be able to take the square root of it. And in that case, note the plus or minus out here as well, that means that we'll get two real answers. So down at the bottom, again, I've got a description of what it does, what the discriminant does. If b squared minus 4ac comes out to a positive number, any sort of positive number, you're going to get two solutions. Or graphically, that means two x-intercepts, as they're pointing to over here at the right. If the discriminant, on the other hand, comes out to 0, then you're only going to get one solution. Because it makes sense, again, the square root of 0 would have been 0, and plus or minus 0, right, over here, means that we just get one answer. Positive 0 and negative 0 really are one thing. So therefore we get one solution, which graphically means, well, we only cross the x-axis once. Your vertex must have been directly on the x-axis, such as it is right over here. Now finally, and kind of the big part to this, if the discriminant, b squared minus 4ac, comes out to a negative number, well, then you're going to get no solutions, or basically no x-intercepts. Taking a good look at that graph right over here, notice we never cross the x-axis. And that tells us a lot, because we won't have to do the rest of the equation. If we're not going to have any x-intercepts, if there aren't going to be any solutions, then by doing the discriminant, we can stop our process early. And we don't have to do a lot of the extra work. Again, where can we use this kind of thing? Well, what if we wanted to know whether or not something went high enough? So let's just say that we had somebody standing at the y-axis, and they're going to throw a football, right? They're going to stand here, and they're going to throw their football, and it's going to land on the ground. And we just want to know, did the football ever reach, 25 feet high? Let's say this is 25 feet, right? Up here. Well, if all we want to know is, did it reach 25 feet? If the discriminant, or if we can set up an equation for that and get it equal to 0 and solve it, if the discriminant comes out to a positive number, then we know it reached that 2 times. If it comes out to an even 0, we know it only reached it 1 time. And if it comes out to a negative number, it means that that football never reached that line, never reached that height. So again, those things can kind of be why we use the discriminant, in various ways. So let's go on to the next page here, and let's talk about the details that go along with the discriminant. Get rid of all that extra writing there. So here are 3 different equations. Quadratic equations, note the x squared in each one of them. And what we want to do is figure out what is the discriminant, and according to the discriminant, how many real solutions or roots to our equation or x-intercepts on the graph will it have. Remember that real solutions and roots and x-intercepts, they're all the same thing. Well, the first thing we need to do is make sure that our equation is equal to 0. So notice over here, we've got this equation equal to 0 for part A here, which is a good sign. So then what we can do is, let's plug this into our discriminant. Now in order to do that, again, we need to know b squared minus 4ac. which means what we're going to have to do is identify a, b, and c. Now, since we're equal to 0, we can definitely do that. Remember that a is the coefficient of x squared. So right now, a for us is a 1. B is the coefficient of x. So again, we got our -3 here. And -4 would be our constant. So let's plug that into our formula up top. B squared, so -3 squared minus 4, note that's always part of the formula, times a times c. Well, that gives us 9. Negative and negative is going to be plus 4 times 1 times 4 would be 16, and it comes out to a solid 25. So that's the value of the discriminant. Now, what does that tell us about the discriminant? Well, a positive number means we would have 2 real solutions. Let's try that with the next equation over here. So again, we're equal to 0, so we're all set there. So let's identify a, b, and c. We'll plug that into the discriminant. So here we go. A is going to be 3. B is going to be -2. And c will be 1. So -2 squared minus 4 times a times c. That makes 4 minus 12 is a -8. That's the value of our discriminant. And again, if the discriminant comes out to a negative number, then we have no... Change colors here for you real quick. No real solutions. All right. Tell you what, for the equation down at the bottom, I'll get you started, but then you go ahead and try that out, and then pause the video, and we'll fill it in here in just a second. The first step, though, notice the one on the bottom is a little different than the other two. Notice that we're not equal to 0 right now. We've got variables and numbers on both sides of the equation. So the first thing that I need to do is actually clean up this equation a little bit. I'm going to subtract 4x from both sides, so that on the left we're equal to 0. On the right, you'll notice we have 3 different terms, none of which are like terms. So we have a 4x squared, we've got a minus 4x, and we have a plus 1. Well, that means that a, again, is 4, b is -4, and c will be a positive 1. Plugging that into our formula, -4 squared minus 4 times a times c gets us a 16. Remember, negative numbers squared become positive. Minus 4 times 4 times 1 would be 16 as well. That means our discriminant equals 0. Right? So that's the value of the discriminant. What does it tell us? Well, it tells us, again, if the discriminant equals 0, there's going to be one real solution. I hope that helps you with the discriminant, finding the value of the discriminant. Good luck. If you have any questions, make sure you talk to your teacher, and have a great day.